Welcome to my NaiveBayes machine learning model demonstration. This is the main menu graphical user interface. Here we can see 3 J buttons, a train new dataset, patient evaluation, and a button for exiting the program. As you can see, the patient evaluation button is disabled until a dataset has been trained. Once we opt to train a new dataset, the user is provided with important information and instructions for the next window. This will open the File Manager page. This is another user interface. This implements a J slider in order to allow the user to specify a percentage of the dataset they wish to train. The remaining data will then be used for self-evaluation of the algorithm and system. Below, we can see a J file chooser, which allows the user to browse their local directories, select a dataset of their preference, and open the dataset. The dataset must be a text file. This is to prevent incorrect user input. Once the file is opened, the program will instantiate a file processor class, which we'll call a read data method. This will scan through the data using a scanner, use a series of if statements and switch statements to match each token in the dataset and each line to a patient. Patient will be instantiated for each line, and all of the relevant data will be stored in each patient object to be used in the NaiveBayes algorithm method, which is called later through a probability calculator object from this class here. The NaiveBayes algorithm works by storing the relevant data in variables, passing these variables to the method. A patient object is passed along with all of the relevant data and counters. This data is used to calculate each relevant probability within the algorithm and stored in an independent variable. These are displayed here as attributes of the probability calculator. Once all of the probabilities are calculated, below is an implementation of the NaiveBayes algorithm using the relevant probabilities. Once this is finished, this information is returned to the user. The graphical user interface implements a feature of self-evaluation. This is returned as a percentage predicted correctly. The patient evaluation button is unlocked once the files are processed. This allows the user to enter a patient with custom symptoms. Once the submit button is clicked, a new patient is created. Custom data is stored in patient objects. It is tested using the NaiveBayes algorithm method from the probability calculator once again. Results are returned to the user, as we can see here. That is my demonstration of the program. Thank you for listening.